This short webinar introduces two new Compute Canada systems, CETA and GRAM. CETA and GRAM entered production in June 2017 and are part of the current infrastructure renewal plan that started in 2016 with a cloud system called Arbutus at the University of Victoria and will end with a large parallel system at the University of Toronto called Niagara at the end of 2017. CETA and GRAM are currently the fastest academic high-performance computing systems in Canada, with close to 30,000 processors and with 300 to almost 600 GPUs. They've been designed as general-purpose clusters to accommodate a variety of workloads, from large shared memory jobs and arrays of serial jobs to very large distributed memory parallel calculations. CETA and GRAM have fairly similar specs, the details of which can be viewed in our wiki pages. Both clusters have a very large number of base nodes with 128 GB of memory and 32 cores per node, 576 such nodes on CETA and 800 on GRAM. In addition, they have a smaller number of large memory nodes, with 256 GB, 512 GB, 1.5 TB, and 3 TB of memory, respectively, to be used for large memory calculations. For example, many bioinformatics codes require a lot of memory in a shared memory environment. CETA and GRAM have different high-speed interconnects, OmniPath and InfiniBand, respectively, but both can support communication between nodes up to 100 gigabits per second. On both systems, nodes are arranged in islands of 1024 CPU cores, and inside each island you get the maximum communication speed. You can also run jobs with more than 1024 cores with a slight drop in performance. Both systems have many GPU nodes, featuring NVIDIA P100 Pascal cards, in the configurations shown in this table. These nodes can be used for general-purpose GPU computing using CUDA, OpenCL, OpenACC, and many libraries and codes that support GPU computing. The GPU nodes can also be used for visualization. About 20% of CETA and GRAM will be available through the default allocation, or what we call the Rapid Access Service. This means that once you have a Compute Canada account, you can simply log in and start submitting jobs. The job's priority will be determined based on fair share, a mechanism that's been designed to give fair access to everyone in a multi-user environment. In simple terms, if you're submitting a lot of jobs, then your fair share level will drop, giving you longer wait times, so that other users could access the resources. After a few days of low activity, your fair share level will automatically recover. If occasionally you need to do more computing than usual, we will have a compute burst mechanism to request higher priority for a short time to complete your larger tasks. Your usage will still be counted towards your default allocation. Rapid Access Service will be sufficient to meet the needs of many users. If you need more resources, specifically more than 50 CPU years or 10 GPU years in a calendar year, your research group can apply for more resources via the annual resource allocation competition. This competition is held once a year in the fall for allocations to start in the following year. If you're interested in applying, please look for an announcement in September in our emails and in Compute Canada and regional consortia websites. This concludes our introductory webinar.